Okay, welcome back. This is the fourth time I've tried to do this video, so hopefully it works this time. Okay, so far we've learned about alkanes. Alkanes have single bonds between the carbons. For example, in this, which is ethane, ethane has a single bond between the two carbons. Now if I added up the number of carbons here, 2, and the number of hydrogens, 6, and then check to see if that fit in with that particular equation, then I would know for sure that it's an alkane. Quick math is, if C to the N, that's 2 carbons, because I just counted them, then I just put 2 in for this N. 2 times 2 plus 2 is 6. So, since C2H6 and C2H6, since those things are the same thing, that tells me for sure that it is an alkane. This is the molecular formula. This is what we call the condensed formula. Okay, so this is the same thing as that, which is the same thing as that. So, when I'm doing this, whatever my structural formula, the easiest way to do it, to identify whether it's an alkane, an alkene, or an alkyne, is there a single bond? Then it's an alkane. Is there at least one double bond somewhere? Then it's an alkene. Is there a triple bond somewhere? That's an alkyne. Okay? So that's the very basics. And you can use that to determine what kind of hydrocarbon it is. Now let's get back to the notes. Sorry. All right. So now we're talking about alkenes. They have at least one double bond. And because of that, we say that they are unsaturated. They're unsaturated because only alkanes are saturated with hydrogens. You can't fit any more hydrogens on there. We also say that they're aliphatic, which essentially means that it's a straight chain. They do have a general formula of C to the N, H to the 2N, as I just showed you on the CRT. C5H10, that means there's one double bond in here somewhere. So C to the 5, H to the 10, 5 indicates pent. And now we're talking about alkenes, so my ending is going to be ene. So that's the equation, the name for C5H10, pentene. And as I just wrote there, they end in ene. So when you name them, it's slightly different. When we were talking about alkanes, we had to consider what the substituents were, and usually went by alphabetical order. Now, with alkenes and alkynes, it's going to be slightly different. What do? You number the carbon atoms starting with the end closest to the double bond. And as always, we're going to do a lot of practice with that. Okay? So, the other thing that is changed here is we have to put a number telling where the double bond is. So, first thing I'm going to do is, how many carbons do I have here? 1, 2, 3, 4. Since I've got 4, I know that the root word is but, as in butane. The second thing that I see here is that this is a double bond. Because that's a double bond, it's not butane anymore. We call it butene. If we did the molecular formula for this, that would be C4, H, 1, 2, 3, 4, 5, 6, 7, 8. This is the formula C to the N, H to the 2N. So this also tells me that it's an alkene. Now as far as naming this goes, I always name the molecule by naming the number of the carbon in which the double or the triple bond occurs. So, in this case it doesn't matter. I could start here, 1, 2, that's the lowest number that the double bond is, or 1, 2. So it doesn't matter in this case. So I'm going to name this 1, 2, 3, 4. So it's 4, but I have to name where the double bond is. So this is 2, and my long chain here is 4, and 4 is but. and I have a double bond, so it's butene. 2-butene. Okay? If the bond were here, it would be 1-butene. And those are the only two that we can have with this one. All right? Next one. What's my long chain? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 seems to be my longest chain. Now, can I start counting from here? 1, 2, 3, 4. Well, where's the double bond? The double bond has to be associated with the lowest number carbon that you can have. So, instead of it being 1, 2, 3, it has to be 1. Okay? So, when I'm naming this, I also have to name the substituent groups. All right? So this one's a little bit more complicated. What are my substituent groups? And by the way, the double bond will always be part of the main chain. You can't go 1, 2, 3, 4 and have this as the substituent. The double or the triple bond is always part of the main chain. So if I go 1, 2, 3, 4, my long is 4, and I've got 2 substituent groups. So what do? They're both single carbon, and remember single carbon is meth, so this is methyl. I've got 2 of them, and when I have them, I have to name the carbon off of which they branch. So I'm going to number this 1, 2, 3, 4. So I've got a methyl group on 2 and on 3. So I'm going to name it 2, 3. There are 2 of them, so I need the prefix di. What are they? Methyl. But now I have to name the double bond. And that is 1. My longest chain is 4. So 2,3-dimethyl 1-butene. 2,3-dimethyl 1-butene. Now to make this a little bit more complicated, it's not my fault, it's just how they did it. Sometimes you'll see this as 2,3-dimethyl but1-ene. I'll write that one in a different color too. You could see it as 2,3-dimethyl but1-ene. Okay, so be used to both of those. All right, next one. Alkynes. Alkynes. All right. As you can see, the ending is going to be y-n-e, -ine. In this case, they will have at least 1 triple bond. Chances are you're going to have only 1 bond. And because they have a triple bond, they're also unsaturated. They are aliphatic. Again, that means in a chain. We use the same nomenclature, which is basically a naming system, as alkenes. So what we just learned with alkenes, we will apply that to alkynes. So let's see if we can name these. What's my long chain? 1, 2, 3, 4, 5, 6. Would it be better to go 1, 2? That's where the triple bond is, or go 1, 2, 3, 4. Well, I want my triple bond to have the lowest number, so this is 2. Are there any substituent groups? Well, here's one right here. What carbon is it on? 1, 2, 3, 4, 5, 6. It's on 4. So this one is 4. What is the substituent group? Methyl. Where's the triple bond? 2. How many carbons is it? 6. Is there a triple or a double bond? There's a triple bond. 4-methyl 2-hexyne. Okay? Let's try this one. 2-bromo-5-methyl-heptyne. Well, heptyne tells me there are 7. 2, 3, 4, 5, 6, 7. All right. This tells me where the triple bond is. 1, 2, 3. There's my triple bond. Now you can stop there and then go to the beginning, or just run backwards. It's up to you. But you have to have all parts of this. I'm going to go to the front this time. 2-bromo. Bromo means bromine. 5-methyl. 1, 2, 3, 4, 5. Methyl. There. I'm not completely done. I've got to put hydrogens around each of these. Make sure each of your carbons has 4. Look at this one. 1, 2, 3, 4. So I can't put anything up here or here. Same thing here. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? All right. Let's name this one. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4. Well, the triple bond is on number 2. So I'm going to start counting from here. That's my long. Okay, so now I can name it. Do I have any substituent groups? I've got one here and here. Now I've got 2 different ones. Since I've got 2 different, we go back to which one gets named first, and we do that alphabetically. So this is 5-bromo, methyl, two, and its long is 6, so that's hexyne. Okay? So that's another challenge for you. So let's look back. Typed naming of organic compounds number 1. That's this one here. There are some halogen groups. We also have a triple bond and a double bond. I want you to try to do this whole thing, then we'll go over it tomorrow. Okay? The other thing is the grading came out today, and I will post that. Basically, you're going to go in 10-point increments. Starts at 55. If you haven't done anything, you're going to get a 55. And it could be this marking period. It's definitely this marking period. And it might be next marking period, depending if we come back to school or not. So it goes 55, then 70, 80, 90, and 100. There's no in-between grade. So the potentially negative thing on that is if you have a 94, chances are you're not going to get 100. You're going back down to a 90. That's just the way that the administration told us how to do it. Okay? On the positive side, if you get an 86, chances are you'll get bumped up to a 90. Okay? All right. I will see you tomorrow.